The last method I'm going to show you for organizing data refers to numerical variables, so those that they are at the interval or ratio level and whose values are actual real concrete numbers. It's called a stem and leaf plot, and it is, even though the name is that of a plot, but it's really more of a table, a way again of organizing data, although it will start to look like a little bit like a graph. It is also not yet a very common way of presenting data, but it is, I'm seeing it a little bit more as the literature catches up with these developments in statistics. So let's see, what is this thing? It's basically a method to group data without losing information. Remember in the last video I said that sometimes when you group data in order to count them and put them in a frequency table, you may lose the original data. You want to keep that. But this allows us to actually display and organize the original data without losing any information whatsoever. So let me give you an example to show you how it is done. Let's say that we have collected a sample of numbers, and these are the numbers that we have. Now, if you look at that bunch of numbers, it looks very scary, but if you notice, actually they're already sorted. They're in order, 17, 18, 21, 22, 24, and so on and so on. But we're going to do something a little bit more than that. We're not just going to sort them, which is what I've already done, but we're going to organize them in a little bit of a more informative way. What we're going to do is we're going to draw a horizontal line and a vertical line. That's not unusual. You have done that before. But these lines are not like the X and Y axis, so they're a little bit offside. So what we're going to do is on the left of the vertical line, we're going to put the numbers that we're going to call as stems. And to the right, we're going to put the numbers that we're going to call leaves. How are we going to do that? Well, let's start from the first two numbers, 17 and 18. You'll notice that these two numbers both have 1 as a first digit, and then the second digit is different. So what we're going to do is we're going to use 1 as the stem and 7 or 8 as the leaves, and we're going to write those two numbers in there in that way. Similarly, if we look at all the numbers in their 20s, they all have 2 as the first digit, so that's going to be our stem, and then the leaves are going to be 1, 2, 4, 5, 8, and 9. We can do the same thing with the 30s, and again, this is going to create a longer list, which is fine. We're just going to make the list a little bit longer, but again, we're going to keep all of those numbers in order and keeping the stem on the left and the leaves on the right hand side. And then we can do the same thing with the 4s and with the 5s. And you can start seeing already there is a little bit of a pattern forming. Remember, that's one of our purposes in organizing data. Try to look for patterns. And lo and behold, the last one is our 72. Now let's see, if I give you a stem and leaf plot, how you can retrace the original numbers. So for instance, if you look at the 2 and the 4, what that means is that there was one observation which had 2 as the first digit and 4 as the second. So that would be the number 24. And of course, that's the 24 that we have there. Similarly, if we look at the pair of numbers 5 and 8, 5 in the stem column and 8 in the leaves area, that means that it corresponds to the number 58, and of course that's the number 58 that we have there. Now notice also that this stem and leaf plot, as I was saying earlier, not only keeps all of the numbers, keeps them organized, keeps them in order and so on, but it starts showing us a little bit of a pattern. So again, this is something that achieves several purposes: keeping the original information, giving it to us in an organized way, in a subdivided way, and at the same time looking for or providing us with an initial pattern for the data. And so this is something again that proves quite useful, although it is not used as much as it could be.